In this video, we're going to look at why the law of cosines works. So we are going to prove the law of cosines. Just as a reminder, the law of cosines says for any triangle with a given labeling convention, we have a squared is equal to b squared plus c squared minus 2bc times cosine of alpha. B squared is equal to a squared plus c squared minus 2ac times cosine of beta. And c squared is equal to a squared plus b squared minus 2ab times cosine of gamma. So our angles are alpha, beta, gamma. Our sides are A, B, and C. And moreover, the side opposite angle alpha is A, the side opposite angle beta is B, and the side opposite angle gamma is C. The key to solving this and showing that the law of cosines works is to draw an altitude. An altitude is a line segment that goes through one of the corners of the triangle and is perpendicular to the side opposite it. So in this case, I've drawn an altitude at the point at gamma that's perpendicular to line C, or line segment C, side C. Now, this breaks C into two parts, two pieces. I'll call the first piece length X, and the other piece will therefore be length C minus X. If C is the entire length of that side, then X plus C minus X will add to C. Note that this altitude breaks up this triangle into two right triangles, one with side X, H, and A, and the other right triangle has sides C minus X, H, and B. So we have two right triangles here, one that involves angle beta and one that involves angle alpha. Let's take a look at the first right triangle, and let me highlight that for you. So that's the one I'm calling the first right triangle. The one on the left, which involves angle beta and which has legs of X and H and hypotenuse of A. Now on this first right triangle, we can apply the Pythagorean theorem, which says the legs squared added together plus, well, is equal to the hypotenuse squared. So in other words, the sum of the legs squared is equal to the hypotenuse squared. On this situation, we have x squared plus h squared is equal to a squared. Now we can also apply SOHCAHTOA to this situation as well. Since we have a right triangle where we have beta here, I want you to notice that the cosine of beta, well, cosine of beta is defined as the adjacent side divided by the hypotenuse. That is the length of the side adjacent to beta divided by the length of the hypotenuse. So in this case, that means cosine of beta is x over a. Now we're going to rewrite that for convenience, multiply that equation on both sides by a, which will give us x is equal to a times cosine of beta. So we get these two equations, one coming from the Pythagorean theorem, that's x squared plus h squared is equal to a squared, and the other coming from SOHCAHTOA, which says x is equal to a times cosine of beta. Now let's look at the second right triangle in this picture. Now the only thing we're going to need on this right triangle is the Pythagorean theorem on this right triangle. This right triangle has legs of h and c minus x, and has hypotenuse of b. So using the Pythagorean theorem, c minus x squared plus h squared will equal b squared. At this point, we have all the information we need, and we just have to apply some basic algebra along with the equations that I already have. So for my first right triangle, I have x squared plus h squared is equal to a squared, and x is equal to a cosine beta. For my second right triangle, I have c minus x quantity squared plus h squared is equal to b squared. So the first thing I do is I multiply c minus x squared out. When I do that, I'll get c squared minus 2 times cx plus x squared. Then we still have the plus h squared is equal to b squared. Now, the x squared plus h squared, because of this first right triangle, we know we can substitute that out with an a squared. So we replace x squared plus h squared with a squared. And we also replace this x in here with a times cosine of beta. So that's what we do. And we do a simple substitution on all of those things, which gives us c squared minus 2 times c times a times cosine of beta plus a squared is equal to b squared. Now, the way that the law of sines is written, we'll have the b squared on the left-hand side. So we'll put b squared on the left-hand side. Then I'll put the a squared up front. So I get a squared plus c squared. And then minus 2ca cosine beta, we can write as minus 2ac cosine beta. So with just a little bit of reorganization, I get one of my law of cosine equations. It turns out if you swap the role of x and c minus x, and then swap the role of the first right triangle and the second right triangle in this same exact picture, you could get the law of cosines that involves the alpha. And then if I use an altitude through either beta or through alpha, that could give me the law of cosines involving the gamma. So all three law of cosines can be given using this scenario. Now, there is a weird situation that could happen if our triangle is obtuse. So if our triangle is obtuse and we want to draw the altitude that is at the point of gamma, which is perpendicular to side C, then I have to extend side C out a little bit and draw the altitude that way. That would give me a supplementary angle to alpha, which we'll call omega here. Now, just as a note, that if we were wanting to find the law of cosines for either beta or gamma, then I could have dropped the altitude to where angle alpha is, and perpendicular to side A. That could have generated the law of cosines for beta and the law of cosines for gamma in this case. So the only one that I need to generate the law of cosines for in this scenario is the alpha, because my other situation would have been like the previous couple of slides for law of cosines for beta and law of cosines for gamma. So the first right triangle is the one that I've highlighted in blue here. I'm calling that the first right triangle. And you can see that it has legs of x and h and hypotenuse of b. X is just however long we had to extend this side out until it hit the altitude. So because of the Pythagorean theorem, x squared plus h squared will be equal to b squared. And also, because of SOHCAHTOA, the cosine of omega will be the adjacent over the hypotenuse. That is x over b in this first triangle case. Multiplying both sides by b gives me x is equal to b times the cosine of omega. And again, omega is the supplementary angle to angle alpha. So they add up to 180 degrees. Now the second right triangle is the one that I've highlighted in red. And you'll notice that one leg is going to be c plus x. Another leg is going to be h. And another leg, or excuse me, and the hypotenuse is going to be a. So the Pythagorean theorem in this case will say c plus x quantity squared plus h squared is equal to a squared. And that's all we need from the second right triangle. Once again, we're going to apply some algebra for this case. The first right triangle says x squared plus h squared is equal to b squared, and x is equal to b times cosine of omega. The second right triangle says quantity c plus x and quantity squared plus h squared is equal to a squared. When I multiply out c plus x squared, that would give me c squared plus 2 times c times x plus 8x squared. And then we have plus h squared is equal to a squared. Once again, now that we have an x squared plus an h squared, I'm going to replace that. That is going to get replaced with the b squared. So that goes into there. And then the x right here is going to get replaced with a b times cosine of omega. So that's what happens. And we get c squared plus 2 times c b cosine of omega plus b squared is equal to a squared. Now, one thing about supplementary angles and cosine is that if alpha and omega add to 180 degrees, then the cosine of omega is going to be the opposite of the cosine of alpha. So now we're going to replace cosine of omega with the opposite of the cosine of alpha. Reorganize, so we'll put a squared on the left, and then we'll have on the right a b squared, a c squared, and then a minus 2bc cosine alpha. And you can see that this involves the angle alpha. This is the law of cosines with angle alpha, and that's the one we needed. And so therefore, in any situation, now we have established the law of cosines. A squared is equal to b squared plus c squared minus 2bc times cosine of alpha. B squared is equal to a squared plus c squared minus 2ac times cosine of beta. And c squared is equal to a squared plus b squared minus 2ab times cosine of gamma. So that concludes this video. If you want to see another video on how the law of sines works, there'll be a link to that as well.